we are going to talk about better batch monitoring. And first thing first, let's introduce ourselves. So Chuck, you want to go?
Yeah, sure. Hi, my name's Chuck Miller. I'm Chief Data Scientist here at Camo Analytics, based in Philadelphia area in Pennsylvania. Started my journey in process analytics and chemometrics in 1985. And so if I do the math, which maybe too soon for me to do that yet, but 30 to 35 years of experience doing PAT and chemometrics, most recently at Merck Pharmaceuticals, but also at DuPont.
Good. And myself, Geir Rune Flåten, I've been working with PAT and related challenges for a while as well. Started out in academia, worked a little bit in industrial company, GlaxoSmithKline, and then I moved to Camo. And in Camo, I'm working with what we call solutions, which is what we are going to talk about today, actually, our batch solution. But the premise of what I'm trying to do is that I'm trying to link our customers with the tools which we have in Camo, and also, of course, identifying new opportunities in terms of developments. But what we are doing in Camo, in sort of the wider aspect, is of course that we are working on in the digitalization space. We are doing multivariate analysis. That's where we are starting from. And that means that we are working with different types of sensors, and we are trying then to develop tools for analyzing these data in a good manner. We are working with a lot of the bigger pharma companies, and we are also working with within regulated environments, and of course. And the last year we actually had two major audits which we passed very successfully, which means that our tools, they are very applicable within GMP environments. PAT is a big thing for us, and this webinar here is a continuation of a recent PAT webinar. So hopefully this will make sense to all of you. And last, before going to the next slide, we should mention that across the world now, we are looking on 3,000 plus deployments of the Camo tool. So lots of people can enjoy those if they wanted to. But this seminar or this webinar here today, this is about batch and batch processes. And in this slide, we are trying to sum up or trying to justify why we want to talk with you about batch. Of course, the major points is that looking out there in the industrial world, still a majority of the industrial processes, they are batch. And also still a lot of those batch processes, they are controlled or run by using recipes. And we think, of course, as Camo and as Chuck and Geruna, we think that we can do this better. First step is to do it in a data-driven manner, which means that we should use the relevant data. And also, we should use these data in the right way, generating insight and understanding. And we don't think that, even though there are some initiatives, we don't think that batch processes are going to go away anytime soon. So on that note, anything to add, Chuck? Or?
Well, no, I know there's been a lot of discussion around advanced manufacturing, and rightfully so. I think innovation is an endless endeavor. So I think rightfully so, continuous and advanced manufacturing should be pursued, and as the business benefits dictate. At the same time, I think reality says that batch processes are here to stay. Some of them around thousands of years, but that doesn't mean they're inappropriate. And with that said, I think there's ways of doing it better, ways of getting more benefit out of existing batch processes.
Definitely. That's what we are going to discuss, right? So the first slide, or the first overview, what we are trying to show here is that, okay, there is a watershed between the traditional way of doing batch, which is about recipe-driven batches, where we are basically having some sort of plan for how we're going to run that batch, and we are running that batch accordingly, no matter what. We want to get into that data-driven paradigm, of course, where we are starting to not only run the batch according to recipe, but also monitor what's going on with this batch and adapting them. And in this world of Industry 4.0 and digitalization and all of that, we have some sort of established steps which we are usually looking at. We are going from historical data analysis, where we're starting to look on existing data, what has happened. As we are getting the insight or the understanding from those historical data, we are maybe able to generate some real-time models, some models we can use in real time, so we can monitor these batches or processes as they are advancing. And then, of course, trying also to have an understanding or an insight, which is making us able to give some advanced decision support. And when we are working in Camo with customers, also with batch, we are trying to reach the stage where we can really support that decision support or provide that decision support. But also there is a future, of course, which is basically that Industry 4.0 or 4.0, which is about autonomous running of our processes. And that's really where we want to get to, but still that is very much the future, I would say. But when we're looking on this, going to the data-driven setup, we have some obvious benefits. They are, so to some extent, generic outside batches as well. But for batches, we have two here, which is about increased quality assurance and also reduced cycle time, which is hugely important. And I think you have some examples there, right, Chuck?
Well, yeah, and just to add to what you said earlier about, again, a lot of, entirely vast majority are recipe-driven batch processes, and there's absolutely nothing wrong with that, of course. But what we're talking about is bringing the data-driven part into that as a supplement to build on top of it, to get even more out of more efficiency out of the process. And so what these business benefits are showing is that, well, the ones that are grayed out are still very relevant for batch processes. But the two that we'd like to focus on, there's actually two examples. One from one of my former employers' processes in vaccines manufacturing, $500,000 worth of waste. Basically, that's the value of the contents of a bioreactor that have to be discarded if there's a quality critical deviation in the process. The 800K in the middle, that's approximate US dollars per month. That's the gained revenue by really opportunity value, in the sense of running batches more efficiently means a sold out product can be run more times per month, therefore better utilization of assets. So that's where those two come from. But by no means are we limited to those two. There's other values as well.
True, and it is significant numbers, right? We are talking real benefits there for sure.
Right. By bringing the data in, on top of the recipe driven, absolutely. Yeah. Sorry.
Yeah. No. but also we are talking about the benefits from our perspective, and obviously we should be doing that because we are working in this space. But what is really nice to see is also that our customers or the people we are working with out there, they are also seeing the same type of benefit, right? And what we have here from Andreas in Bayer is a really nice statement about how PAT in general, this is his statement, wasn't limited to batch, but it applies to batch as well. And he's saying that, okay, there are some immediate benefits here from doing things in the right way, using PAT, using data-driven approaches. And there are also some future benefits here in terms of possibilities and opportunities for process optimization and cost reduction. And that is really underlining or supporting the point we made in the previous slide, right?
Right, absolutely. The last point there about undreamed of possibilities. I kind of like that terminology. As we'll show you later, there's benefits you might not be aware of by adding data into the batch control monitoring.
Exactly, and that's also what we are going to try to point to today, because we want to take this step and, as we say, move beyond the traditional batch. And traditional batch in this context is really about recipe-driven or suboptimal use of the data, right? And if we take that step and start to look at that, very much, if we are looking up here in the left-hand side or left-hand corner, the fundamental thing to do here is about having the right sensor, so we are getting the right data, and then ensure that we are applying or employing the right methods to those data. And if we are successful in doing that, then we can move all the way over here, and we have the improved overall equipment efficiency. Because basically then we are getting all of those benefits which are listed up here, and we are turning that into improved operations, which is reflected in that type of KPI which OEE is.
Absolutely. Yeah. All of these items are very relevant in batch monitoring context, and things I like. Only emphasis I want to add here is around life cycle considerations and management. Managing all this data, managing all these batch context and so forth.
Yeah, I think that is really summing it up for now, because what we are thinking about when we are thinking batch here, we are really thinking about some steps taken from that recipe-driven historical way of doing batches, all the way into that closed loop control, where we're actually using the data in the right way and trying then to ensure that the system or the batch is more or less self-controlled. But on that part, there are a couple of steps starting from recipe-driven. We have the first step, which is about univariate monitoring. We have some data from our batch. We are starting to look on those data maybe in real time, but typically it's just the one variable or the one parameter we are looking at any one time. Then when we're getting to the next level or the next advancement level is data-driven approaches, and here we are taking more of the data. We are starting to use the data in a more sensible way, and we are then starting to getting a better picture of what is the state of our batch. And that state of the batch is really what we are trying to monitor or trying to model when we are into that trajectory monitoring. Because then we are looking on the transition, starting from the raw material through that chemical operation or the biological transition, all the way to the end product. And we are trying to understand, okay, what's happening here as the batch is taking the journey from input materials to end product. And of course, if we have a fundamentally good understanding of all of this, then we can look into having some closed loop control. Maybe initially something which is driven or controlled by people, overseen by the operators, but in the future, somewhere ahead there, maybe this batch is able to run itself more or less, that it's actually able to adhering to the changes which is detected through the batch. And here I think the green one here, we can see this, the green sort of incline. We can see this as an increase in benefit and basically savings of running those batches.
Yeah, what I'm looking at, the way I like to look at that, this is sort of progressions of levels, kind of like the PAT 5 stages for those who were involved in the PAT webinar. More integration of data into the recipe approach. So, this level 2 is what I like to call more the passive, more traditional univariate type monitoring. But then going from 2 to 3, we start to do a little bit more sophisticated math with the data, things like moving block, multivariate monitoring. So do a little bit smarter monitoring, more efficient monitoring. But then from 3 to 4, now we're starting to actively model not just passive, just points in multivariate space. We're actually monitoring the trajectory in the space, meaning that each batch would nominally go through a specific pathway. We expect to see that, and if we don't see that, then we have to take action. And then the final level here is about closed loop control, meaning very active usage of the data in terms of both not just monitoring but control.
Yeah. And that is increasing complexity, but also increasing benefit, I think we could say. Would you agree with that?
Yeah, that's fair. That's a fair statement, yeah.
And if we are looking then on a batch, this is just a simple bioprocess as we can see it. We have a reaction vessel here. We have some controllable input factors coming, which we can sort of adjust as we are running this batch. We have some input factor which is not possible to control, of course. Could be things like environmental variables, depending on how well we are controlling those on the vessel itself. And then, of course, we have those outputs or the responses coming out of that. And if we take an overview then of the data sources and the opportunity we have there, we see that, okay, we will have possibly some indication or some information about our raw materials we are putting into the batch. And as we are running this batch, depending on the setup, we might have some process data, we might have some at-line data, maybe some glucose measurements or something like that, which is done at-line. And also, of course, we might have some sensors which are sort of measuring the batch as it's running. And this is then the real-time data which we have available. While on the right-hand side here, this is the idea that, okay, when the batch has done or completed its transition, we have that product and we are getting the quality data for the product. And this is pretty much standard for all sort of batch processes, wouldn't you say, Chuck?
Yeah. It's kind of surprising to see that a relatively simple process can have many, not just a lot of different types of, a lot of different data points, but different types of data. And from a logistical standpoint, from a model building and monitoring perspective, it does become complex. And so a simple platform solution might not get it done. You've got lots of different types of data, different frequencies, different types of context, and so forth. That really you want to bring together. And so there's some logistical challenges here, but there's again, like you said previously, it's more complex, but the potential benefits are quite high.
Yeah, and this is really to the point. Since you mentioned platform, I can mention one, right? This is obviously our own platform. Yeah. This is our ProSupport, which in combination with Undreamed, where we are running or creating models, we can actually take in data and run real time, and we can deal with that and we can watch that, right? And of course, in the batch context, that means that we can have a monitoring of the batch, independent of the data, really, which is describing that batch. And we are not going to talk about data and types of data as such today. We're going to focus a little bit on what we can do in terms of that batch modeling and the trajectory part of the batch modeling. But first, this platform, when we have a platform, obviously today we are going to talk about batch monitoring. This is our focus and this is sort of the topic of the day. But with the right setup, with the right platform, of course we can do other challenges along the way. Blend monitoring, of course, another batch process, but a different type of solution or challenge. And we can look on these different type of setups, or these different type of problems one might experience in the process. And this is really what we can do.
Yeah, this is a nice example. When we just say batch, a lot of folks will say, well, batch is sort of a monolithic category of all types of one type of monitoring, when in fact, batch monitoring has lots of different types, lots of flavors, many of which are shown here. And so I know, Gabriel, I think we have some examples, on our website, we have some examples of each of these types of solutions. And again, with the exception of maybe the top right, continuous manufacturing, which is by definition not batch, sort of batch, but all of these are different flavors of batch, and so it's not just suffice to say we do batch monitoring. We do distinguish between the different types of batch monitoring.
True. But today we are focusing on batch, and we have an example here, and this is penicillin fermentation. We have some input variables. We have the process, the transition, of course, and then we have the output variables, where we are sort of assessing how has this batch been performing for us. And what we've done then is that we have recorded a little bit of a demo. This is just showing in our tool in the platform ProSupport how we would do this. And the first thing we do, of course, is that we are logging in to the application, logging in because we are in a regulated environment, and that means that we need to ensure that the access is restricted. And what's happening on the screen now is that we are digging out that batch application or that PAT method, which is batch. We are putting in this contextual data, very outline of data here, but it's things like the project name, it's the product, it could be really anything depending on what type of context we want. And when we are starting then this configuration, we see that, okay, we have that trajectory which we have been preparing in advance in the modeling tool. And as we are starting to run data through this application, we see that we are moving in the trajectory, and also for each new point, for each new measurement, we are getting these variables or the values for the different variables. We can track it as contributions, which is compared to the model, or we can track it as raw data. And of course, if we are drilling down on one of those samples or one of those measurements, we can also go in and see for each variable now, what is the level in that point. And that means that we can sort of have a track or have a handle on how our batch is performing, not only in relation to the trajectory, but also on each point within that trajectory. And what we can do then, as the trajectory is progressing, is that we can look on different stages in the trajectory, marking where we are and where we want to be, and then drilling down, and we can see the group 1 where we have a lot of glucose. That's a start point, that's reducing. We can also look on those other variables, how the variables are changing through the batch, and this way we can sort of follow the whole development. And the same development we see in the drill downs is also what we see in that raw data plot, where we, in this case, are mapping the biomass concentration, and as that is increasing, as is the ethanol concentration, while the glucose concentration is decreasing, of course, because that's the food for these bacteria. And this way then, in real time, we can have a very good understanding about, okay, what's going on, how are we performing compared to our expectations. Anything to add to that, Jack?
Yeah. Well, a couple things. One is you'll note the upper plot is scores plot, but it's not just any old scatter plot. This is a trajectory scores plot. So remember, level 3 to 4, a little bit more advanced modeling here. We're not just doing multivariate. We're not just doing PCA monitoring here. We're modeling actually the trajectory or the pathway within the PCA score space. That gives us more specific, more relevant both outlier diagnostics. The Hotelling t-squares and q-residuals are actually calculated relative to the mean trajectory and not relative to the center point of the PCA. Yep. So that's more relevant. The other and the more practical feature here, I really like seeing the contributions, the dynamic contribution bar plots as one progresses through the fermentation in this case.
Yeah. Oh no, that's exactly right. And what we are thinking now, of course, is that we have some suggestions about what is a better way forward. And we have we only have 6 minutes left, Chuck, so time is flying here. But we have some keys here in the different areas on how we can succeed. And of course, what we are doing very much process, technology, and people. And are there any special items you want to pull out?
Well, yeah, we could talk for hours about this. Obviously, I mean, there's lots of keys. These are challenges, or sometimes roadblocks to consider. But one specific one that I find is the challenge is the top left sensor recalibration. So when we do a multivariate model, the sensors, those sensors get recalibrated and they get offset occasionally. So we have to have a management around that. I'll pick that one, and you can pick one or one or a couple more to go after. There's lots in there.
Then maybe I should pick something here in technology, right? Because this thinking about having some flexible, scalable, and compliant tools, I think that is really, really important, right? Because we need to start out right, and then we will end up in a good place, and I think that's important. And of course, there is also this, those of you who attended the PAT webinar, this point here about, okay, if you don't know everything yourself, maybe talk with someone who knows, whether it's a university or whether it's Camo. But have a chat with people who have been through this.
And then one more. I just wanted one more. Context. Data context. Very important. Putting in a batch solution, automation, underlying automation system, you really need to have good context data. And I'm talking about batch identifiers, procedure, phase identifiers, things that could be used to trigger starts and stops of monitoring configurations.
True. And success, what does that look like? It is the business benefits we have pulled out before, of course, and it's pretty generic across the PAT methods. But the surprising thing here is that, okay, we have those standard business benefits, but we also have these additional benefits, right, Chuck?
Absolutely. I think some of these I like to call like surprises, like I referred to earlier. Upper left, QN, quality notification. Having a data historian, relevant data historian available with plots readily available to support investigations and streamline investigations because some poor soul has to write a report after a deviation, and you want to make their job as easy as possible. Other things around utilities and preventive maintenance, even the health of control loops. You could use monitoring to determine whether a local control loop is starting to fail. A couple of good examples we can share about that.
Yeah, and what we've been doing now, of course, is that we've been scratching the surface a little bit, but it's not comprehensive. We haven't been digging deep, and of course time is flying, so we won't get much further today, but we are planning to have some future expert discussions, both roundtable discussions, but there is also an opportunity, of course, to contact us directly, and we can have chats with you about your specific batches. And this webinar here, this is really one in a series, and we are talking, it's going back to those solutions we talked about earlier, right? That we have some upcoming solutions webinars where we're trying to talk through those different aspects of running your processes in a good way. And the next one, which is planned, is November, better reaction monitoring, and then there is one in January as well. And what we are going to do now is to answer some questions, and I received some already. So what we can start out with then, Chuck, is the first question here, which is, where is the biggest potential / upside in improving our batches? Any opinion on that one?
Ooh, where's the biggest potential? Again, it's tough to pick one out, but I know just my bias, having recently come from pharmaceutical industry and biotech specifically, cost of goods and services, COGS, that $500,000 per discarded batch for a vaccine formulation. That's just the cost of the materials. We're not even talking about the cycle time, availability of the production hardware. So that's less waste, that's more efficiency. Potentially for that scenario, I think just material cost is pretty high. So you're not discarding, you're discarding less material. So if I had to pick one, that's my bias.
Yep. Good. Thank you for that. And there are more questions. There's one about, okay, what is ProSupport? No, is ProSupport suitable for early development work without using chemometrics and models? And I can answer that because I've been working a little bit with solutions and ProSupport. And yes, ProSupport, it's a data management platform really. So it is able to connect to data sources and run chemometric models, or you can also just run the raw data through and store that in the database if you want. And between running the raw data and running chemometric models, it's also possible to run what we call online calculations, which could be things like ratios or just summing different parameters or doing other sort of relationship calculations. So yes, for sure, it doesn't have to do the full monty of the advanced modeling to have benefit of ProSupport.
That's a really good question. Yeah, if I may add a bit, this reminds me of one of my Merck directors approaching me about doing putting an analytics platform on a pilot plant, vaccines pilot plant, and what's the value in that? You know, he challenged me, and rightfully so, challenged me like, what's the value here? And one of the answers I had was, well, it's first of all, you're curating data here. You're aggregating data. You might not even need to build a model. You're just pulling the data for later use. Second thing I had was with that data in hand, sometimes it's used. One value proposition would be later on when you want to scale up, or if that product is commercialized. And you know, we're talking about scaling up vaccines like COVID vaccines. Some of the most valuable data for such scale-ups and commercialization are the early development data at small scale. And we kind of wish, I could tell you a longer story, but kind of wish we had more of that with the Ebola vaccine. I wish we had more of that early development data readily available to help commercialize that vaccine a few years back.
Yeah, and I guess the same applies for development, that if you start out right, it's much better chance for actually ending up in the right place, right?
Yeah, it was a tough sell, I'll admit it. Yeah, it was a tough sell, but I think it's a valid point. And that's a very good question.
Okay, I have another last question here, I believe. The question is, what if model requires more than two principal components to explain the process? And I guess that's referring back to the demo we did with the trajectory scores. So is this one you want to address, Chuck?
Well, I could try. Yeah. Well, they're actually the batch trajectory model in the current version of Unscrambler Batch does go up to 3 PCs for trajectory modeling. With that said, I also would say that in the past, when I've done some monitoring, a lot, especially biotech upstream cell culture processes, typically for monitoring purposes, we haven't really needed to use more than 2 or maybe 3 TCs in the model. Mainly because the monitoring mission is not a predictive model. It's not like the analytical PLS traditional predictive type model, and so we're not if we underfit the model a little bit, it's not that devastating because we're really monitoring both the outlier metrics, the t-squared and the residual. So in a way, trying to use a higher order model, a higher factor model for monitoring purposes might not even be that valuable. But with that said, we still go up to 3 PCs in the trajectory.
And I think I want to expand a little bit on that as well, Chuck, because what we want to do, of course, is that we want to monitor the transition which is relevant in the batch, right? So we should probably put a lot of effort into doing the right pre-treatment and pre-handling of the data to ensure that the data is actually capturing the transition itself, right? So we're not modeling something which is maybe systematic, but not really relevant to the batch transition, right? So there is that. And I have a
scaling,
final
like you said, or selecting the right variable.
I have a final.
Sorry, go ahead. No, I was just to mention, emphasizing the importance of scaling, variable scaling, and exclusion and selection of variables when you're doing the monitoring model. And that oftentimes brings you back down to maybe a simpler space model to a rank model of maybe 2 or 3. So anyway.
Yeah. There is a question here about whether there is any risk to the batch approach, which we are suggesting here. What would you say there?
Yeah, okay. To be totally fair, I think one of the biggest challenges we had at Merck was the QA regulatory posture around passive monitoring, multivariate monitoring. And how does quality handle? How do we handle this from a QA perspective? And that's a serious question, because an inspector shows up and sees a monitor, process pulse monitor up there, they're going to ask questions. They're going to, rightfully so, again, because it's so there was a lot of discussion, and I think where we came down, at least in this specific case, was that these there are some risks involved, and a lot of times these monitoring methods will produce a lot of what I'll call false alarms, false negatives, and so there needs to be something in the quality, in the SOPs and the quality to specify how to handle false alarms. But also but really the bigger problem is the false negatives. So you want the monitor to see something that's real. If it misses something that's really happening, then it kind of fails in its mission. So there are risks involved, no question.
But would you say, because clearly that is something which is operationally important, and it needs to be adapted or sort of fixed in order to be operational relevant. But would you call it true risk? Because it's more inconvenience, isn't it? It's not really risk to doing anything wrong, and it's not necessarily risk to getting off track with this approach.
Well, I like to think of the false alarms as more annoyances, but the false, I don't know if risk is the appropriate word to use here, but I think it's not a freewheeling enterprise where we could just do whatever we want. There has to be some structure in how the batch monitoring is done, and there has to be some codification and procedures to satisfy the authorities that might come by, whether they be local or just your internal QA as well as outside.
Couldn't agree more, but I think that the biggest risk here is to start out doing something which is not the right thing to do, right? So talk with somebody who knows. But I think that when you're doing it right, it's pretty standard and pretty safe.
Yeah, absolutely.
I'm getting more questions here. So I can just continue asking the questions. But there is one here coming in, which is about whether it's possible to generate statistical process control charts using this approach or this platform. And of course it is, that is part of it, because we're starting from the univariate monitoring, and then we are moving up to the multivariate monitoring. So it's there is no harm, and there is also a lot of benefit in using the univariate statistical process charts, which is or control charts, which is very widely used. So that's one. And this is the final. I have one left there, but take the opportunity to remind you that please feel free to send in questions as well if there are things you are thinking about in hindsight, or if you're watching this video back in a recording. But the final question.
Oh no, can I just went at one more point that reminded me of CPV. So SPC, for those who aren't familiar with what CPV means, is continued process verification. And so it's kind of what I'll call a batch level quality tracking, or batch level SPC. And Process Pulse does have some capability around. In fact, we do have an actual installation that's doing CPV, tracking both raw material QA data with process data with product quality data, all in the same CPV reporting template. Sorry.
True. No, that's fine. Thank you for the clarification, Chuck. But the question I had there was, will the batch model give the control instruction for the variable that leads to the deviation? And I can start answering that at least, because in the view I showed, that's basically just drilling down to the actual variable which is causing the deviation. And that means that the control instruction itself is not part of that. But it is worth mentioning that we have been looking on a sort of an interface where we are translating the deviation or the sort of movement in the spore space into actual control action or suggested control actions. So it is something we have been playing around with, and it is something which is possible to talk to us about, but it's not part of that standard way of looking on trajectory models. It's more what we call dynamic KPI, and it's something we are doing in a layer or a product which we call reporting layer. So it is possible, I would say. Anything to add to that?
Yeah. The dynamic KPI was what came to mind. That tool, that's a layer on top of Process Pulse, I understand. And and I think the challenges around control, again, that's like I think we got to that fifth level of or even adaptive or predictive control Certainly, there's nothing that prevents Process Pulse. Process Pulse has output capability to control systems, automation systems, and so if you want the local machine or process control system, the Delta V, whatever the Honeywell system, to govern the control part of your mission, then it's certainly possible for Pulse to submit to that controller PVs based on, or multivariate PVs or process variables to drive that control. But like everyone has said, there's some work being done on some control, I guess, realization of control models instead of just monitoring models.
So. Yes. Thank you for that, Chuck. And I think we will wrap it up there. As I said, it is possible to ask questions in email or contact us directly. Because what we've been doing today is, of course, as I said before, scratching the surface here. And it is possible to go deeper, and there's a lot of interesting stuff going on here, right?
Absolutely. We could be here for hours, but I know we all have other meetings and things to do. Yes. So certainly, but like Garuna, like you said, it's got opportunities for follow-up here. So please take advantage of those. We're here. We're here for you.
Yeah. So it just remains to say thank you very much for the attention, all of you guys following this, and take care.
Yeah. Thank you.
Yep. Bye-bye.